This video is on graphical representations of data. The first type of statistic graph we're going to look at is called a dot plot. This is a frequency plot, and it's called that because it shows how many numbers of times a response occurs in a data set. Each data value is represented by a dot. So on this dot plot, you can see there were 4 occurrences of the number 4. There were 4 occurrences of the number 3.5, 2 occurrences of the number 3, 2 occurrences of 2.5, 1 occurrence of 2, and so on. This is a nice plot for showing the shape of the data. For instance, you could tell very quickly if you had most of the numbers lying in the middle of the set, or at the bottom or the top of the numbers in that range, and it shows the trend well. But if you have a lot of data, making a dot plot could be very time consuming. The next type of graph is a histogram. This is also a frequency plot because it shows how frequently each piece of data shows up. It shows the number of times a response or range of responses occurred in a data set. Sometimes on a histogram, instead of just seeing a 60 down here, you'd see something like from 50 to 60, and the bar would show everything that occurred in the data set between 50 and 60. This is great for looking at the shape also, where in this graph you can see that most of the data occurred around 100, give or take, so maybe between 90 and 110 were the highest occurrences. But no exact values show here. So we don't know exactly what the numbers were here. We only know that a little more than 25 occurrences happened between 100 and 110. The next type, and the one we're going to focus on most, is called a box plot. You might have seen this called box and whiskers because the center here is always a box, and there's usually some lines coming off each end, and those would be the whiskers. A box plot shows a minimum, the lowest piece of data, the lowest number, a maximum, the highest number piece of data, the first quartile, the median, which you've already heard about, and the third quartile. We're going to discuss the quartiles in a minute. In the meantime, let's just look at the way this box plot appears, because you will be making them as well. The middle 50% of the data is indicated by the box. So 50% of the data lies in here. Now sometimes your box is longer and sometimes it's shorter, but half of the data in the set will always be contained in that box. 25% is between the minimum and sort of the bottom of the box, so the first quartile, and the remaining 25% of the data is between the third quartile and the maximum. And so this gives us a lot of information about the data. Let's take a look at what I mean by quartiles. Here we have a set of data ranging from 65 all the way up to 100. These are already in order, and you can see that there are some numbers that are repeated. The median is the middle of the data, and if you recall when we talked about median, sometimes it's called quartile 2, and that is the exact middle. In this case, the median is 80. So when you look at this set of data, let's see if we can put the 80 there. The first quartile is actually the bottom, or the middle of the bottom half. Look at the bottom half of this data. Everything below the median is called the bottom half, and the middle of it is 70, and that's quartile 1. Now look at the top half. of this data. The top half of the data is everything above the median. And so the middle of that, I have 1, 2, 3, 4, 5 pieces of data above the median. The middle, 2 on each side, is 90. 90 is the third quartile. So quartiles are just middles of different parts of the set of data. Quartile 2 is called the median. It's the middle of the entire set. Quartile 1 is just the middle of the bottom half of the set, and quartile 3 is the middle of the top half of the set. We'll have some more practice with that, but let's take a look at another new term called the interquartile range. We use IQR to abbreviate this because it's quite a mouthful and it's a lot to write. Interquartile range. The interquartile range, if you remember, just range was the difference between the biggest number and the smallest number in a data set. Well, the interquartile range is the difference between the third quartile and the first quartile. And this can be found by looking at the box. Remember what I said, the first quartile was the bottom of the box, and the third quartile was the top or right side of the box. And so if you subtract those two numbers, third quartile minus first quartile, that is called the interquartile range. And we will practice all of these. Right now I want you to just get familiar with the terminology. The next term is called an outlier. And you've looked at outliers before, probably in middle school. An outlier is a value that is either much bigger than or much smaller than the rest of the data in the data set. And usually we can tell just by looking at the set of data if the number sort of stands out, if it's way bigger or way smaller. But just saying that it's a lot bigger or a lot smaller is a little bit vague. Like, how much bigger or smaller does it have to be considered an outlier? And so there's a rule mathematically that we use to justify definitely whether it's an outlier and doesn't just appear to be an outlier. You can see a picture here. All the data is plotted here, but then there's this one piece of data that looks like it's all the way out here, not with the rest of the data. This is clearly an outlier. If you can take quartile 1 and subtract 1.5 times the interquartile range, or, and if your answer is less than that, then it's an outlier. If it's greater than your piece of data now, if your piece of data is bigger than quartile 3 plus 1.5 times the interquartile range, it's also an outlier. So what we're saying is you take the interquartile range, you multiply by 1.5, 1.5, and you can't go that much smaller than quartile 1 to the left of the box, or more than that much bigger than quartile 3 to the right of the box, or it's an outlier. I know that sounds confusing, but once we practice it together, it's really not going to be too bad. Let's look first at an example of a box and whisker plot that we can do together. All right, so here's our data set. It's the same one from earlier. The summary statistics that we need to be able to make a box and whisker plot are quartile 1, the median, quartile 3, the maximum, and the minimum. Work with me. Pause the video if you need to copy this down. Make a number line. Don't fill in the numbers yet, and we'll talk about what needs to go where. So when you have a number line, and you need one to look at a box and whisker plot, we need to decide what numbers we need to have included, because numbering this from like -10 to +10 won't do us any good. Look at our data. Our data is between 65 and 100. So we probably want to start a little smaller than 65, and we want to make sure we have enough room on our number line to get at least to 100, maybe a little bit over, just to leave some room. So what if I start at 50 and I count by fives? 50, 55, 60, 65, 70. These are hard to fit. I'm going to skip every one. 90, 100. Oh, that's plenty big. So let's take a look and see. And you could have spread it out more. Let's look at the data first. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. It's easiest to find my median first. If I have 10 pieces of data, 5 are going to be on either side of the median. 5 below the median, 5 above the median. So I can see that my median falls between these two numbers, but they're both 80, which means that the median is just 80. Remember, that's quartile 2, or the median. Quartile 1 is the middle of everything below the median, and the middle is right here. This will be quartile 1. Quartile 3 is the middle of everything above the median, and this is the middle. Notice there's 2 below it, 2 above it, so 90 is in the middle. This is quartile 3. Notice if I label everything, then I've got it all there. And if quartile 2 or the median fell on one number, I would have just circled it as well. I only draw a line in the middle to help me remember that it's between those two numbers. Okay, so quartile 1 was 70. Our median, or quartile 2, was 80. Quartile 3 was 90. The maximum is the biggest number. Nothing fancy going on for maximum and minimum. The minimum is the smallest number, 65. All right, so to draw our box and whiskers plot, we're going to make a dot at our maximum and our minimum. The maximum is 100. We're going to go above our line, not on it. The minimum is 65. Now, our box is quartile 1 and quartile 3, the bottom of the box, the top in the box. So I have 70 for the bottom of the box, 90 for the top of the box. So I'm going to draw my box. And now the median, which is 80 in this case, gets marked with a line inside of the box. So it's always very clear to us. Quartile 1, quartile 2, or median, quartile 3. And all you do is draw in the whiskers. And that's our box plot, or box and whisker plot. There are some advantages and disadvantages to box plots. It shows the 5-point summary, and if there were outliers, you could just show them as a separate dot outside of the maximum and minimum. It easily compares 2 or more data sets because we can just use the same number line and draw multiple box plots above or even below that number line, and we'll have practice with that as well. It also handles extremely large data sets easily. The problem is we don't know what the exact values are because we don't see those. We're just talking in more general terms using quartiles. It's also not as visually appealing as the other graphs. We can see so much information as far as how often something occurs on histograms and dot plots. But box plots are useful in many cases, and we're going to practice working with them some more.